Okay, we'll start now. Is it visible?
Yes, sir.
Okay. We have already discussed in our physical classroom that about your ozone in troposphere or as a pollutant. This is a secondary pollutant causing photochemical smogs or Los Angeles smog. And there is a chain of reaction of this photochemical smog formation which will initiated by oxides of nitrogen, and you can say this is the precursor of ozone formation in troposphere as a pollutant. The oxides of nitrogen, basically NO1 and NO2, so they may be considered as indirect greenhouse gases because they are causing secondary pollutants. Also, they have the global warming potential. They can consider as greenhouse gases, but they have an indirect effect through a chain of photochemical reactions and sometimes thermochemical reactions to produce these secondary pollutants like ozone or your PAN, peroxyacetyl nitrate. Apart from these oxides of nitrogen, there is an important role of your alkyl or you can say your hydrocarbons along with your hydroxyl free radical in formation of these secondary photochemical smogs. So ozone is a important allotrope of oxygen when you say its chemistry. So in chemical formation, this is the nascent oxygen is there, means this is the atomic oxygen. Then your molecular oxygen, whatever you need for your living cells to survive, for the respiration processes and other oxidation processes. Along with this, ozone is three oxygen composed molecule, which has some important features to absorb ultraviolet region energy, high energetic photons, and they have a vital role when they are forming this layer in the stratosphere. Means this is the upper tropospheric layer. This is the second strata of atmospheric layer beyond 20 kilometer of height, approximately up to 50 kilometer of height, means altitude. We can face the stratosphere and your ozone layer roughly between this 25 to 35 kilometer of altitudes. And what is the role of this ozone and how it will be formed and how it will be break down in a natural way, and what is the role of chloride free radicals from chlorofluorocarbons and other free radicals and other elements or molecules in degrading or depleting this ozone layer. Means there is a ozone breaking and formation cycle which is naturally occurred in the stratospheric ozone layer, and some is man-made or anthropogenic induced, some chemicals are there or free radicals are there. Those are very important and responsible for this ozone depletion processes. And sometimes the ozone depletion is so intense at certain areas, we can consider those points as ozone holes. Okay, we will go for this. Then in this part, we will discuss about what are the ozone and what is the structure of this ozone layer, then formation of this ozone layer, and what is the null cycle, that is called your Chapman cycle of ozone formation and destruction. Then catalytic destruction of anthropogenic molecules induced ozone layer depletions. Then your phasing out of chlorofluorocarbons in Montreal Protocol or Vienna Conventions, and what is the impact on this global ozone layer protection. So all these things we have discussed, we have to discuss in this lecture. First is your ozone layer. When you see the ozone layer, first question arises, what does the ozone layer do for us? We know that ozone layer is the only major atmospheric constituent that absorb the ultraviolet region energies or photons or light energies. Your ultraviolet region starts below 340 nanometers. You can consider from 280 nanometer to 315 nanometer as a intermediary UVV or the intermediary ultraviolet region of spectra, that is called UVB spectra. After this UVB spectra, you can have the lower energy, higher wavelength UVA spectra, and again shorter wavelengths, lesser than 280 nanometer, are considered as UVA or strong energetic ultraviolet radiations. So you can see that from about from 100 nanometer roughly to extended up to 340 or 350 nanometer, the range is called UV region, which is again split into three spectra, that is UVC, B and A, when wavelength is increasing in this range CB to A. So ozone can absorb lights mostly in 210 nanometer and 290 nanometer. Both are in intense UVB and C regions. Without it, life have some remained underwater. And that means underwater life have uh, created the situation of oxygen saturation in the atmosphere, which may cause your ozone formation in the history. That means you can say the ozone layer is a consequence of ozone only chemistry. It formed once photosynthetic marine organisms like cyanobacteria and algae began so-called polluting the atmosphere with oxygen. That means there is a font statement we are using here, that is polluting the atmosphere with oxygen. What do you mean by this? Actually, they are not polluting the atmosphere with oxygen. Cyanobacteria and algae in prehistorical states, they produce this oxygen in numerous amount. The oxygen concentration will increase in the atmosphere, that may cause, in presence of some photochemical reaction from solar light or solar energy, it cause the formation of this ozone due to plenty availability of oxygen. So for that reason, we can say ozone formation may caused by the cyanobacteria or algae due to this oxygen increasing concentration in the prehistoric stages or the beginning of the life forms. So actually oxygen is not polluting, but if you see the history of the ozone formation or the beginning of this ozone formation, then it starts from this oxygen. Okay, are you getting what I am saying? I think you understand what I am saying. Anyone have doubt on this slide? Here you can see this UV range, and this is your UVB spectra up to 280 to 320, then 320 to above are the UVA spectra. And ozone will absorb in this region mostly from 280 to 320 nanometers. Okay, we'll go ahead. So what happens here? Attenuation of the solar flux occurs in the stratosphere. What do you mean by attenuation? Attenuation means decrease in the amplitude of any wave is called attenuation. That means we are decreasing the energy levels, because amplitude also directly proportional to your energy content of any electromagnetic radiation or any type of wave energies. So ground level sunlight is limited to wavelength less than 290 nanometers. Stratosphere filters out the light energies between 180 to 290 nanometers. So there is a spectral window centered at 205 nanometer, that is in the UV light region or UV spectral region, that penetrates more deeply into the stratosphere. So you can find here at 205 nanometers, somewhere here we will have a spectral window. Means there is a filter is working in the stratosphere in the form of this ozone layer, which can form a layer to filter this portion of the UV spectra. And at a peak of this 205 nanometer, they can most efficiently absorb this flux. So you can have this actinic flux density, which you have a spectral range at peak at 205 nanometers. And then you can see due to this absorbance of this ozone layer, we can have an atmospheric window that below this height of your ground level, or below the height of this 50 kilometers, you can't see all these radiations due to this presence of this ozone layers. So is there any query about this slide? I want questions, because if you really need to understand the things, if you not, I don't help you. This is your photon. Here you can say 10 to the power 9, 10 to the power 10. This is the number of photons per centimeter square per second per nanometer. Means this is your photon flux density, and this is the quantification of the energy intensity of the solar energy. UV absorbed by dioxygens and ozone. And what is the content here? Here we are discussing the efficiency of dioxygen and ozone, how they absorb the UV. If you see here, absorption of cross section of this factor of oxygen, means oxygen, molecular oxygen, you can see it will absorb at 140 nanometer to 150 nanometer. The peak is here. You can see the peak. This is the absorption peak, and this absorption peaks is very intense UV ray A region. Means very high energetic radiation is absorbed by this diatomic oxygens, or you can say oxygen molecule. This oxygen molecule have a band of absorption that is called your Schumann-Runge bands, and this is your band of absorption. That band is varied from this 175 to 205 nanometer ranges. And you can see the ozone. When you see the ozone, you will have this 250 nanometer, around 250 or 260 nanometer. There is a peak ranges of absorption of ozone layer, and this range will go further higher if you will go for the UV rays A regions. Means if you will go for the longer wavelength, means lesser energy, the ozone can absorb, but it can effectively or efficiently absorb in the region of this UVB region, that is lies between 240 to 260 or 70 nanometer, like this. So this is your absorption of this ozone at stratospheric UV radiation. So you can compare here. Molecular oxygen have a very strong band of absorption of energy, whereas this ozone molecule have somewhat lesser energy. It can absorb, because ozone have triple bond. If you see the flexibility of bonding pattern or lone pairs, then you can see that the absorption band will go in higher wavelength region, means lesser energy it can absorb, the molecule can absorb, but the amount of absorption may be increased. Means it can absorb more and more amount of photons, but not the intensity or the energy content being the higher one. Okay, so we'll go for the next. Any questions on this? Suman?
Yes, sir.
Are you listening?
Yes, sir.
There is no question.
No question, sir.
So बुझिए जाउछि रे.
Yes, sir.
Okay, good. We'll go for the next. Then you will have the health effect of ozone depletion. So that is very obvious, and you know that the health effect will have the more intense UV radiation if it will go through the atmospheric window and fall on the surface of a tissue of any living organism, then it will have a very bad impact. So the biological damage function as the function of the wavelength, that is B lambda. Here it is your biological damage potential, and in F lambda is the function of the light that penetrates to the ground level. The two different column of ozone levels, that is normal and depleted. You will have a normal and depleted, both type of column, and there is a impact you can see in terms of your B lambda. Okay, this is your B lambda, means biological destruction, and it is your F lambda, that is your what? It is your light penetrate through the ozone layer, and the product of B lambda F lambda gives an indication of additional biological damage potential caused by the ozone depletion. That means you can see here there is a two line, that is one federal line is there and the one solid line is there. The federal line, you can see this is your depleted ozone, and what is the intensity of light passed through this depleted ozone layer. Depleted means there is a 250 Dobson unit of thickness. What do you mean by Dobson unit? Anyone can?
सर जो ओजन का जो adoption माने जो
One Dobson unit is equal 0.01 millimeter of
millimeter
thickness at 0 degree centigrade and 1 atmospheric pressure of the ozone. Okay. So when the thickness decreases, means some depletion occurs. That is 250 Dobson unit is in federal line, and 348 Dobson unit is in solid line. So if it is solid line, so that is the atmospheric window from through which the light radiation will pass through. Means the amount of light that penetrates to the ground level through normal conditions and depleted conditions. And here
Sir, one
B
Dobson unit is equal to?
huh?
Sir, one Dobson unit is equal to?
0.01 millimeter. Okay.
Okay.
Here you can see here the biological impact or biological damage is a function of the product of this light energy penetrated through the ozone layer, and what is the biological damage occur. This product will increase when the depletion have certain depletion occurs. Means if it is 340 Dobson unit to 250 Dobson unit is depleted, then you can have a significant magnitude of biological damage. You can see here in this figure. You can see here this figure is the depleted ozone layer biological impact, and this is your original or normal biological impact. So you will have a enhanced biological impact, means bad impact or adverse impact or health effects. Okay, due to this depletion. You can see here the depletion will cause a little amount of stray light, or you can say somewhat of UVB radiation will get into the atmosphere, but they can cause a huge magnitude of change in biological impact or health impact. I think you will get my point. Jadis 10 nanometer रो भी जदि UV radiation extra band टा पास करिके आसिला ओजोन लेयर देई, ताहले से गोटे सिग्निफिकेंट हेल्थ इंपैक्ट देखेइबो सब एनिमल उपरे. से यही एटी कहबा को चाहू. Next. So about the ozone layer, I think we have already discussed about the ozone layer in our paper 1, means 101. Okay, the stratification of the atmosphere. So you can see here the ozone layer is in between the 15 roughly 15 kilometer to your 30 kilometer range. It may not be at 15 kilometer, it may be from 20 to 25 or 25 to 35 sometimes. So this is the rough range. This red region is the rough range of this ozone layer, where intensely from 20 to 25 kilometer it will have the more concentration of these ozones. So then you can have the question that how we can say that there is approximately 300 to 350 Dawson unit of ozone in normal condition of the atmosphere. If we say 300 to 350 Dawson unit, that is the normal ozone layer thickness. So if one Dawson unit is 0.01 mm thickness, then what is the amount of 300 Dawson unit in thickness? Can you express in the centimeter? It is somewhere at 3 millimeter. So actually this is not the figure what you are understanding by sentence of this statement. This is the 3 millimeter thickness at 0 degree centigrade and 1 atmospheric pressure, but not the prevailing temperature whatever they are in the atmosphere. In the stratospheric layer, if the prevailing temperature and the atmosphere pressure will change, that means that thickness or density will change. So we consider this thickness almost at these temperature profiles, means 1 atmospheric pressure and 0 degree centigrade temperature. And if we condense this ozone layer of thickness, what 3 mm approximately, or 3.5 mm thickness of this stratospheric ozone layer we can find. Then another question arises, if that is a very small thickness of this ozone layer, how can it spread from 15 to 35 kilometer or this 20 to 30 kilometer range? That should be an obvious question, but no one is asking now. Can you answer? I have the question. अरे आमे जदि कहूचे एटा 16 रु 35 किलोमीटर भितरे ओजोन लेयर टा अच्छे, किंतु एबे आउ कहूचे जे ओजोन लेयर बेसी थिकनेस वाला 3.5 मिलीमीटर, ताहले से 3.5 मिलीमीटर थिकनेस वाला ओजोन लेयर एते 10 15 20 किलोमीटर व्यापिक केमिति अछि? Are you listening? And no one is listening.
Yes, sir.
Okay, so এটা ए लेयरटा एमती वेव हेकी अछि, माने गोटे कम थिकनेस गोटे लेयर एमती जिगजैग वेव हेकी स्प्रेड हेकी अछि ओवर दिस 20 किलोमीटर अल्टीट्यूड हाइट. बुझ परछ कि नहीं? এটা গোটে থিকনেস হেকি यूनिफॉर्म बा होमोजेनियस लेयर नुह, एटा बुझि पारलो तो?
Yes, sir.
Okay. And the maximum concentration of this ozone layer is found in 23 kilometer, and maximum relative concentration about 35 kilometer, that is 10 to the power 13 molecules per ml, or you can say that is up to 10 ppm at 35 kilometer. 10 ppm means 10 parts per million. And here you can see here 10 to the power 13 molecules per ml. How can you understand this unit? That means 10 to the power 13 number of ozone molecule per ml volume of air can be present or may be present as maximum absolute concentration, and which may be found between this 20 to 25 kilometer of ozone layer. This is the maximum concentration. If you consider the properties of the gas, or if you remember back to your school days about the gaseous state in your chemistry chapters, you can find that the liquefaction of gases, you can find the system of this Charles law and Boyle's law concepts, compressibility concept, real gas equation. Then you can imagine that you can compress a gas molecule to a very small extent, means it can have a very small volume, it will acquire to have this huge amount of or number of these gas molecules, because gas have intermolecular distance, a distinct intermolecular distance, so you can compress it. Next is your structure of this ozone layer. We have already discussed this about the structure of this ozone layer. So you can find this structure, this ozone number or density, and this density in terms of 10 to the power 10 molecule per centimeter cube means ml cc. Cubic centimeter means 1 cubic centimeter, almost 1 ml is equal to 1 ml. Okay, so you can have this 10 to the power 10, 10 to the power 11 and 10 to the power 12 molecules per cc, means ml of this gas concentration. Here it is in the x-axis, and in y-axis you can see here pressure per millibar. Pressure per millibar, that is not per millibar, that is pressure in terms of millibars or in units of millibar. That means when you go up to the air or altitude, the pressure will drop. The pressure will drop in what quantities? Anyone can answer? I have already discussed in some previous classes. Pressure केमती drop करे? आमे adiabatic lapse rate भी पढ़िथिले. Temperature केमती drop करे सेठी कुआ भी इतला जे pressure केमती drop करे. Pressure drop करिवार scale को आमे scale height बेली कहू. Almost half pressure है जाए 5.6 किलोमीटर height रे. Minus RT by ln mg is the scale height, by virtue of which means in exponentially you can have this decrease in the pressure. That is in E terms or E folded, you can have this decrease in pressure when you go in altitudes. So pressure will drop, that is 1110 and 1, and you will have this when pressure is dropping, as well as your number of ozone or ozone density will drop, number of ozone per ml of gas or ml of air, or you can say your ozone number density will decrease because pressure will decrease. And this is the second graph. Here is showing this altitude in kilometers, and here the ozone mixing ratio means what is the parts per million of ozone by volume. So that will also have this maximum volume. There is 8 ppm, that is at the altitude somewhere at 35 kilometer height, and it is between 25 to 35 kilometer of height. So we will have the maximum parts per volume of the mixing ratio of this ozone. Okay, so here from this graph we will have this observation that ozone is not the most concentrated gas in the ozone layer, not even close. Maximum concentration is in the middle stratosphere. Okay, so why does ozone layer exist in the stratosphere? Why not it will responsible formation and its maintenance? I have also this question asked in some later classes and already answered. And give me the answer. Anyone have this answer? We have already discussed why ozone is in stratosphere, why not it is in troposphere? Because ozone is heavier than oxygen. Oxygen is available in troposphere, but why ozone is in stratosphere?
Due to paramagnetic nature.
Diamagnetic.
Diamagnetic nature.
Diamagnetic by nature. है ओजोन टा डायमैग्नेटिक बाय नेचर से रिपेल हो जाए अर्थ फ्रॉम मैग्नेटिक फील्ड को, अर्थ सरफेस ठार से दूरी जाए. तापरे आ गोटे कथा हला कोन सेई ओजोन टा आमर थिबा गैसेस पॉल्यूटेंट सब बेले स्ट्रेटोस्फेरिक गैसेस और गैस मॉलिक्यूल्स एंड ट्रोपोस्फेरिक गैस मॉलिक्यूल्स माने इंटरमिक्सिंग काई हो नांती. व्हाट इज द कॉज? ए माने मिक्स काई हो नांती. ट्रोपोस्फेयर गैस स्ट्रेटोस्फेयर को जीवा, स्ट्रेटोस्फेयर गैस ट्रोपोस्फेयर को आसीबा बहुत डिफिकल्ट. ये केबे मिक्स हेई पारे ना. व्हाई? एडा भी डिस्कस कर
सर.
सोनाली कोन पई रहि था? सोनाली कोन पई? रोजालिना कौन पाई स्ट्रेटोस्फियर गैस टा ट्रोपोस्फियर को काई पळे आसुनी बा ट्रोपोस्फियर गैस स्ट्रेटोस्फियर को जाई पारुनी तमे एना कहबो कि जदि जाई पारुनी ताले पोल्यूशन होउची केमती ओजोन डिप्लीशन होउची केमती होउची in certain condition, that is when cumulonimbus cloud formation occurs, that is a situation, and intense low pressure occurs, that is another situation. In both the situation the tropospheric gas may enter into the stratospheric gas, but usually it cannot be intermixed. Say question ala why kahe ki usually eman intermix ei parnate stratosphere ro gas molecules or troposphere gas molecules. Rosalina, Akanksha,
Yes, sir.
why?
Sir,
What is
it
the
is
main cause of this restriction of the stratospheric layer to the tropospheric layer, or intermixing between these gases, molecules, or other species of gases, or radicals or ions? Why they are not intermixed?
because the ସେଇଠି ଗୋଟେ barrier ବି ତ ଥାଏ ନା ମାନେ ଗୋଟେ layer tropopause ଯେମିତି ସେମିତି stratopause ଥାଏ stratosphere
No. Tropopause, stratopause are not the barriers. They are only the theoretical concept to divide these um, layers, and they are some physical characteristics or certain physical characteristics. But that is in we are imaginarily defining these layers. There are no physical barrier is there. Okay.
yes sir
Actually, there is a barrier that is called your what? Inversion layer. Your tropospheric temperature will drop up to tropopause, that is maximum minimum of minus 60 degrees centigrade. Then again it will increase up to 0 to minus 2 degrees centigrade up to stratopause. That means there is a temperature inversion occur at the tropopause level. So that is the significance of tropopause, where we define this layer imaginarily because of these physical characteristics. So there is a inversion layer exists at that height of this troposphere, that is between 16 to 20 kilometer height or altitude, that obstructs the intermixing of stratospheric species into troposphere or vice versa. That may be a question in any type of competitive examination. Okay. So we'll go for the discussion about the Chapman cycle, means how naturally ozone will form and ozone will degraded. There is a natural cycle. Always, every time ozone is formed and degraded, ozone is formed and degraded. That is called your null cycle. Okay. So in 1930, Sydney scientist, that is Chapman, proposed a series of reactions to account for the ozone layer. That is called your Chapman cycle. So there are four chemical reactions. One is initiation of the cycle, that is when molecular oxygen will break down in presence of UV light to what? Two atomic oxygen species or atomic oxygen free radicals, and for this breakdown of this molecular oxygen, we need 120 nanometer to 210 nanometer of photon. That means very high energetic UV radiation. Then this propagation of this chain reaction will occur by this atomic oxygen species will add to your molecular oxygen species in presence of a third body to have your ozone. This ozone is generated in this chemical reaction, will generate some heat, and this third body will be responsible to absorb this heat. This type of reaction also occur in tropospheric ozone formation. We have already discussed yesterday in the physical class. So this ozone plus this UV light may then break into molecular oxygen and your atomic oxygen, and this breaking for this breaking you need 220 nanometer to 320 nanometer of spectral region of photon. That means to formation of ozone, to formation of the ozone, we need some lesser energy, lesser wavelength or higher energy than the breakdown. For breakdown, we will have very certain UVB and some part of this UVA spectra of ultraviolet region. Means the energy required for this breakdown is more important than breakdown of this molecular oxygen, which is a precursor to formation of this ozone. That means you can say for formation of ozone we need more energy than the breakdown of energy. Then this termination of this the chain reaction will occur when this ozone and this atomic oxygen species will get combined to have two molecular oxygen species. That means we will have a oxygen species first, and in the last we will get that oxygen species. Means molecular oxygen we have, and we will get this molecular oxygen at the end. So this is a cyclic process. So you can see or visualize this in this picture very clearly. You will have oxygen, this is the photon, this will break, and then it will cause this ozone, and the ozone will break to this oxygen, and this is the process when your molecular oxygen will form ozone and then it will break down to molecular oxygen again. So this is a null cycle. This is, you can say, oxygen only chemistry. That means there is nothing else is participating in this chemistry. There is only oxygen is participating along with some amount of light energy of the photon. So you can have this odd oxygen species. That means only O or O3 are rapidly interconverted. That is OX is equal to O plus O3, and this is called your Chapman cycle or null cycle of ozone depletion and formation. So this evaluation of the Chapman's model, this is qualitative agreements are there to predict the stratospheric source of ozone, and it will also predict the thermal inversion in your stratosphere, whatever I have now discussed, that thermal inversion in stratosphere. And for quantitative agreement, check by comparing measure of ozone levels of this predicted of Chapman model. Means why we accept the Chapman model, that there is a qualitative agreement, there is a quantitative agreement. For qualitative agreement, we have two reasons, or you can say we have two rationale why this Chapman theory will be accepted qualitatively. One is the stratosphere as a source of ozone. Yes, stratosphere has a source of ozone. Another is thermal inversion occur at stratosphere. Yes, we know that there is a thermal inversion at the stratosphere. As quantitative agreement means it is by comparing the measured ozone levels with those predicted by Chapman model. Means when you go for the measurement of the level or your number of molecules, or you can say your molecular density or parts per million by volume, if you go for this densities, the determination in terms of number, then you can find the Chapman model will works well, or it can justify quantitatively also. So what is the problem with this Chapman model? This qualitative agreement is presence of an ozone layer at the right height predict the thermal inversion, but predict is too much ozone. What is this concept or this statement have wrong? That is either there is an extra source of this odd oxygen, or there is other things or pathways that destroy the ozone. Yes, that must be the second one. That means some other sources are there which destroys ozone, and it can have dissatisfy this Chapman model. For that reason, we will face some extra ozone depletion or a constant ozone hole formation. Are you getting my point? That means here there is anthropogenic pollution is there, and some anthropogenic molecule will deplete the ozone other than some natural process. For that reason, Chapman model have some problem. So here you can see this what is that other thing or other source sinks of this ozone. Means if the ozone will destroy, then other, what is the other means of this destruction? The destruction of ozone through some catalytic reactions. First, you can see here in presence of oxides of nitrogen, or in presence of hydrogen oxides or hydroxyl free radical, or chlorate free radical, or chlorine free radical, or bromine free radical. So how these free radicals will, you can here denote as Y, that will have the impact of breaking this ozone to its oxides formation and molecular oxygen formation. And again, these oxides combine with another oxygen species or oxygen, atomic oxygen, to have the molecular oxygen formation. That means ozone will break to two molecule of oxygen, two molecule of oxygen molecule, means gaseous oxygen, and you can have this third body Y released as a catalyst. This catalyst may be out of this four one. Okay, it may be NO, it may be OH dot, it may be Cl dot, it may be Br dot. You know that in chlorofluorocarbons, this chlorine or bromine are there, and these are some naturally occurring tropospheric species which may get into the stratosphere due to the cumulonimbus cloud formation. Sources of this catalyst. This stratospheric, the sources are tropospheric sources, that is N2O, that is a natural gas formation due to the microbial biodegradation processes, and then some natural sources are there, and 10% increase in 800 since 1850. This oxide, nitrous oxide. Then stratospheric hydroxyl free radicals are the sources from tropospheric methane formation, hydrogens, and moisture content of water vapors, and some natural sources are there. 150% of the increase in tropospheric methane since 1850 due to agricultural activities, land filling, and other sources. And stratospheric chlorine and bromine almost entirely due to the human activity. This is only the anthropogenic source we are injecting into the troposphere indirectly to the stratosphere by the sources of this tropospheric emission of the chlorofluorocarbons and hydrochlorofluorocarbons and halogens and etc. before your Montreal Protocol, that is your 1987. You can have some questions that what are the CFCs or chlorofluorocarbons, and what why we are using this or in the past. Okay, these chlorofluorocarbons, they are small molecules that contain chlorine, fluorine, and carbon atoms. Usually they are only 1 to 2 carbon atoms, and these chlorofluorocarbons are sometimes called freons. Chlorofluorocarbons are referred to a number, that is CFC11, CFC12, CFC113, and you can have this splitting of this by adding 90 to this number. Then you will have a 3-number digit. The 3-number digit stands from number of carbon atoms, number of chlorine atoms, then number of fluorine atoms, and rest is to satisfy the catenation property of this carbon with your hydrogen atom. You can find the total molecular formula due to in terms of IUPAC in a nomenclature system of chemistry. Are you getting my point or not? I don't know. Are you getting this? Why this? How we can make out the structure of this chlorofluorocarbon from this nomenclature? If you have CFC12, then you can just add 90 with this 12. 102 is there. So here you can have number of carbon atoms, number of hydrogen atoms, number of chlorine atoms. Sorry, number of chlorine atoms and number of fluorine atoms. You can add this, and the rest number is your hydrogens. So this is your chlorofluorocarbon, and it is mostly used for refrigeration and fuels and solvent processing industries. And most stratospheric chlorine in anthropogenic, this is primary sources of chlorine entering the stratosphere in early 1990s. That is mostly CFC11, CFC12, CFC113, HCFC22, and these are. And what is the percentage? And this portion is your natural contribution in terms of chloroform. And this destruction of ozone layer by the CFCs. CFCs produce this chlorine free radical and chloride free radical. This chlorine free radical and chloride free radical can cause destruction of this ozone layer by formation of molecular oxygen and chloride, and it will split into this free radical by absorbing less than 225 nanometer of light in the stratosphere. By photodissociation, it will produce the free radical. That free radical will drive this ozone depletion process in the stratospheric ozone layer. Okay, atmospheric fate of chlorofluorocarbons. This is the vertical concentration profiles of hard chlorofluorocarbons consistent for the long stratospheric lifetime. It has a stratospheric lifetime more than 500 years also. Some have 100 years, some have 500 years. So it has very long residence time. For that reason, it is very dangerous to the stratospheric ozone layer. These are the concentrations or volume mixing ratios of CFC12, CFC11 and CFC10. And these are the chlorine and these free radicals in the stratosphere, Cl dot and ClO dot. Sometimes some chlorine reservoirs like HCl dot or ClONO2, HOCl, hypochlorous acid, and hydrochloric acid or hydrogen chloride gases are also cause ozone depletion. You can see here the chlorine in the stratosphere, and these are the different form of chlorine in the stratosphere, and these are main precursors or main culprits which will cause destruction of the ozone. And relative contribution of the ozone loss by all these species. They have a role in ozone depletion, and what is the contribution? In this graph, you can see the highest contribution in very shortest span. You can see that is your bromines. You can see a relative contribution of ozone loss by different family of species. This is the banding pattern, or this map shows the highest concentration is at 50% the dark region, and then 20 to 50% the faded region. And you can see here the dark region is there at which type of latitude and which type of altitude you will have a most dark region. You can see here when it will increase, your latitude will increase up to 90, then you will have most ozone layer depletion. You can see here, or loss of ozone you can see here. But that is in Antarctica, in polar regions, so we can see the ozone holes. Also here you can see also. Here the ozone hole is there. Ozone hole means from 340 or 300 Dobson unit, it will reduce to 220 Dobson units due to this chlorofluorocarbon and its impact on ozone depletion. And detection of Antarctic ozone hole, you can see this is the concentration profile of ozone hole at 1986 and 1987, after which there is a monetary protocol to ban these chlorofluorocarbons. And this core of Antarctica vortex will main cause of this unique meteorological condition in the winter season that will cause the ozone depletion mostly at the South Pole regions. This polar vortex. Polar vortex is a cold wave. This is a disaster, and that will cause a situation of this polar stratospheric cloud, and the temperature will drop to minus 40 to minus 60 degrees centigrade. And also the stratosphere have the lesser altitude at poles, that is at 8 kilometer height maximum, and at crystalline formation on this ozone layer, when the photon or the solar light fall on this winter morning, then it can split this ozone very easily, and this temperature profile only maintained at this south pole region due to presence of the continents and some industrial activities of these continents in the arctic region in the north pole. This type of situation of a polar stratospheric cloud occurs very least. For that reason, the ozone hole have less visualization in this north pole and more visualization in this south pole. The polar vortex or the this polar stratospheric cloud and its temperature profile in the winter is the important reason why we can see this ozone depletion in the south poles. Three competing theories are there. This is chlorine induced reduction or circular driven reduction, that is your vortex or this your cold wave, and some is called solar storms, that is oxides of nitrogen created in the upper stratosphere during this winter. They are the three theories which can suggest why ozone hole occurs in polar regions. This is the concentration gradient develop across this vortex. Why vortex is important cause of this depletion. You can say it is a smoking gun, point out to chlorine. And here the chemical reaction at this vortex. That means in darkness on the in winter night, it will form the these chlorine free radicals, and these free radicals are accumulated in this polar region. When in the light or rising spring sun occurs after just winter, then this light will cause or it will supply you the requisite amount of photons or the energies, and which will cause the depletion of this ozone layer at this polar conditions or stratospheric condition. This is how this ozone hole occurs. This is a very good slide. You can follow this step by step. In winter, in polar winter, how this chemical species formed, and in polar spring morning or spring light time, how this chemical species have goes on this photochemical reaction step by step, and ozone depletion occurs. And you can see this is almost in 9 kilometers of height or altitude, Antarctica region. So you already know about this global ozone depletion and its scenarios, and this is this ultraviolet region and its ultraviolet radiation and its changes, which will drive the ozone changes. And you can see the prediction of this Montreal Protocol on stratospheric chlorine free radical Cl dot. So this chlorine free radical will have decreased after this Montreal Protocol. If there is no protocol, then it may increase in this graph, predicted graph. In 1987, that is a Montreal Protocol or ban of chlorofluorocarbons that will restrict this. And in submission, another climate change submission at 1990 of London, this this will have again flatten the curve, and it will go down the curve at Vienna Convention in 1995 and Copenhagen at 1992, and mostly at Montreal at 1997. It will have declined the curve. Now you can see the ozone hole is not visible and ozone repair is visible. So
Sir?
Yes.
सर एटी मॉन्ट्रियल प्रोटोकॉल 1987 रही 1997 डबल तो ही नहीं
ସେଇଟା ତ
क्योटो प्रोटोकॉल
ହଁ ଶୁଣ ସେଇ ଜିନିଷଟା ତମେ ଥାର୍ଡ ସେମିଷ୍ଟରରେ ପଢିବ। ଡବଲ ନୁହଁ, 1987 ପରେ ପ୍ରତ୍ୟେକ ବର୍ଷ ତାର ମିଟିଂ ହୁଏ, ବୁଝିଲା?
यस सर
ପ୍ରତ୍ୟେକ ବର୍ଷ କିଛି କିଛି ମଡିଫିକେସନ ଟାର୍ଗେଟ୍ସ ଦିଆଯାଏ। ଯୋଉ ବର୍ଷର ମଡିଫିକେସନ ଟାର୍ଗେଟ୍ସ ଟା ବେଶୀ କଣ୍ଟ୍ରି ଆଟେଣ୍ଡ କଲେ ତାକୁ କଣ କରାଯାଏ ना बेसी पॉपुलराइज करा जाए बुझी पारलो
Yes,
सेंति
sir.
हमरो 1992 रे क्लाइमेट चेंज समिट हेतिला रियो डी
At
जेनेरियो रे ताकोंते आर्थ समिट हां तो 1992 पर सब वर्ष ही के आछे आदि जाके मझरे गोटे दिटा वर्ष खाली छाड़ी करी सेने मॉन्ट्रियल जेबे हला मॉन्ट्रियल पर तार सिक्वेल सब हला मीटिंग ता सिक्वेल मीटिंग रे डिफरेंट टाइप रो सब बैन कराला जते बेले मॉन्ट्रियल प्रोटोकॉल ले जो जो क्लोरोफ्लोरोकार्बन बा ओजोन डिप्लीटिंग सब्सटेंस गुडा को बैन करा हैतिला ता परे पुणी 1990 रे जते लंडन ने तार हला सिक्वेल मीटिंग सेठी आउ किछटा ऐड कराला वीएनआर आउ किछटा ऐड कराला कोपेनहेगन आउ किछ स्ट्रिक्ट कराला मॉन्ट्रियल आउ टिके 1997 ने आउ थोर स्ट्रिक्ट कराला केवल नाटा दिया है कौन ना जो जगह रे मीटिंग टा हला से जगह को नहीं तार कन्वेंशन नो ना दिया है 1987 रे मॉन्ट्रियल हेतिला पुणी 97 रे मॉन्ट्रियल हला बुझी पालो
yes, sir.
रियो डी जेनेरियो रे क्लाइमेट चेंज कॉन्फ्रेंस का 1992 रे भी हेतिला 2002 रे भी हेतिला ता परे भी गोटे थोर हेची मो डेट ईयर टा मन पड़ो तो सेमती हुए
Yes, sir.
Actually that's all about ozone photochemical smoke ozone chemistry everything of this atmospheric chemistry part you should follow any environmental chemistry for the first portion of this unit that is free radicals and ions and pollutants in the atmosphere very easy thing is there and we can have question overall this okay and I think I will have another class of about your radioisotopes of the previous unit. Then we will close the class for this semester and the second semester class will start. Okay. If you have any question, I will post this PPT in your group, and this is a very good PPT. You can follow for your notes. Okay. Any questions? आउ के किछि पचार नांदे हाउ गोटे पोस्ट कर दोछि तुम पढिबो डाउट हेले पचारिबो हला फिजिकल हां गोटे क्वेश्चन फिजिकल मोड रे क्लास आसीबो की आई एम आस्किंग आई नीड द आंसर
Yes, sir.
No, sir.
Yes, sir.
ए रह जा
No,
रह
sir.
जाओ यस नो टा मत देखियार भी अछि ना राइट हम दे जेठो बाहर एबे नो के कोच खाली कहलो
No, sir.
Shreya have some problem because she do not have any hostel accommodation. Any other? Okay, किछ कहू ना तो
No, sir.
Sir, it's me, sir. Sonali, sir.
Sonali,
No,
I
sir.
don't think you have some problem, but you leave this place due to this you are asking. Saurabh, what is the problem?
Sir,
Sorry,
I am
sir.
not in Bhubaneswar, sir.
Where you are living?
I am in my village,
Huh?
sir.
Puri?
I am in my village, sir.
Why you are at a village? Because in all Odisha there is the latest notification about this your lockdown. It is already opened. No lockdown is there. And also higher education have the notice ki you should have physical mode of class started by higher education department. Due to some common features or blended mode of study may go on. Due to this suggestion, we may go for online classes, a few online classes. जेहेतु हमको यूजीसी सजेस्ट करछे कि तमे ब्लेंडेड मोड रे भी पढ़ी पारिबो एवं सेही पिला माने न आसिले चलिबो जो मानकर देह खराब अछि निजर किंबा फैमिली रे माने दे हैव द पॉजिटिव रिपोर्ट ऑफ कोविड-19 बुझी परछ ना नाही सत्य कथा होछ एटा मु स्ट्रिक्टली से कथा कहूनी बट तमे बुझिथिबा दरकार जे एक्चुअल कॉस्ट कोन जदी तमको कोरोना किंबा फैमिली रे अछि यस यू शुड बी देयर आमे जो भी क्लास एटी पढेबु तार गोटे ऑनलाइन क्लास होबा कथा इफ देयर इज नो प्रॉब्लम लाइक दैट यू सपोज टू कम काहे कि ना तुमे जदी खबर नै पारो तमर माइक्रोबायोलॉजी एंड बोटानी ये दीटा जांकर बैच रो पिला समस्त आसुचंती फिजिकल मोड रे क्लास करूचंती इन वेरी गुड नंबर्स माने भलो अटेंडेंस ताकर अछि जे आसीथिले क्लास मन देखिथिले so HOD is asking that why your people are not coming so I don't have any cause मो पाखे किसी कॉज नहीं देखिबार हम कहि पारंती कि दि चार जन को कोरोना है जाय सर काहे कि डाकिबा मो कथा बुझुछ ना सो मोर कहया कथा कि मु तुमको कंपेल करने कि तुम आस बट द नेचुरल सिनेरियो कि समस्त आछंती बट यू पीपल्स आर नॉट इंटरेस्टेड टू कम हौ एबे सिना कर दबो या एई सेमिस्टर रो परीक्षा तमर हो 13 तारिख ठार 13 14 15 16 बोले 17 माने एई भले अछि 13 प्लस ठारू तमन बोधे एग्जाम गुडा को अछि बुझिला ना तो से एग्जाम टा परे तो तुम आसियो पड़ियो सेतोळ कोन करियो सेतोळ किछि बहाना चलियो
सर आमे जेवा पर रेडी थिले सर आपण से टाइम रे जो कहिले ना 2 दिन क्लास हो तापर पुनी छुट्टी हे जो माने सेई टाइम रे हमर ओडे आरआई एग्जाम थिले सेति में आमे पळे आसिलु
छुट्टी हे जो
रविवार दिन
तुम कहल 2 दिन क्लास है
ना
छुट्टी
माने सर सेमति नहीं सर 2 दिन क्लास हो तापर
हमर एंट्रेंस अछि किछि दिन बंद होबो 2 दिन 3 दिन हां क्या कहली
ना सर एंट्रेंस पर नो सर हमर एंट्रेंस रो सरला पर 2 दिन खंडे क्लास हो
एंट्रेंस तो 31 अगस्त रे सरिला आज तो होउची 4 सितंबर मु तो 2 रे बोधे करछि 3 रे बोधे क्लास करछि आज 4 रे करछि 2 रे हेछि नै मोर मन पड़नी 3 रे तो हेछि तमर क्लास माने काली हेछि आज हेछि 31 रे तो सरला बॉटनी रो एंट्रेंस कथा बुझुछ ना नाही नाही सेकरा छाड़ो मु तुमको बाध्य करनी तमर जहा इच्छा कर मोर किछ कहबार नै बट एई जिंसटा तम एग्जाम जाके ठीक अछि बुझिलो ना तापर जदि लॉकडाउन हे गेला इट्स ओके तमे घर रहला हम सेम ऑनलाइन ने चलेबा तम पाई भलो मो पाई भलो अरे ऑनलाइन क्लासेस रे सबुठार जदि काहार प्रॉफिट ताल टीचर रही तमे बुझुनो कथाटा आमे शांति रे निज घरे बसी पढ दे परछु बट आई एम ओरिड कि तम ऊपर बैच जो पास आउट गला ना से बहुत कथा जानि पारलेनी दीदीटा सेमिस्टर पढ़ी पारलेनी ऑनलाइन क्लासेस रे बहुत डाउट्स रही रह जाए आउ आमे क्लियर करिवार भी किछि उपाय नाही काहे कि हम पाखरे सोफिस्टिकेटेड ऑडियो विजुअल सिस्टम नाही माने मत से जिंसर दुख अछि काहे कि ना सेमिति किछि थांता कि मोड बोर्ड रे भी पढै पारन तमे देखि पारन सेंटा सिस्टम अछि बट हम पाखे नाही बुझि परछ ना नाही सो देयर इज सम लिमिटेशन इज देयर सो देखो एई जदी तमर जदी इच्छा नाही मोर किछ कहबार नै ऑनलाइन क्लास हो आ 2-3टा तो क्लास होबई हो मोर किछ कहबार नै ऑनलाइन क्लासेस करो ऑनलाइन क्लासेस सरी गला परे तुम एग्जाम दियो एग्जाम परे किंतु यू हैव टू कम टू क्लास इफ देयर इज नो लॉकडाउन बुझेला सर बुझेला सोनाली
सर मु तो
हमें जिबो सर
तो एमपी माने पूरा स्ट्रेंथ थ्रू हाफ भी आसिलेनी तो मु पळे आसली सेतमे भी मो मोबाइल भी प्रॉब्लम सर त आपण स्ट्रिक्टली कोहंतु जे स्ट्रिक्टली यू हैव टू प्रेजेंट देले हम समस्त गले ठीक ठाक सो क्लास प्रैक्टिकल सब ठीक से ही परियो भी
हां
आपण से जे
मोर स्ट्रिक्टली कहिबाटा तुमको मु कहि देली जे मु केवल तमरो सेमिस्टर एग्जाम जाके आई एम नॉट स्ट्रिक्ट एट ऑल तमे जा करछो करो से ऑनलाइन ने करी के हमें चले दबा मोर क्वेश्चन हैला आफ्टर योर एग्जामिनेशन जेतो सेकंड सेमिस्टर फुल फ्लेज रे स्टार्ट हबो सेते बेले जदी लॉकडाउन नाही यू हैव टू कम सेते बेले पई कहि दउ स्ट्रिक्टली आसे पड़े सेते बेले मते आ कहियो सेते बेले केवल फिजिकल मोड रे क्लास हो नो ऑनलाइन मोड आ जदी लॉकडाउन थिबो ताल हबो ऑनलाइन मोड हैला नो प्रॉब्लम आई डोंट हैव एनी प्रॉब्लम आ मु स्ट्रिक्टली काहे कहबी सोनाली मते तुमे कहउछ जे आपण स्ट्रिक्टली कहंतु मु स्ट्रिक्टली कहबी ना तुमे बेसी इंटरेस्टेड हबो आई डोंट थिंक सो कि मु काहे स्ट्रिक्टली कहबी तमे न आसो के मते सुविधा हो
हमें इंटरेस्टेड थिलु बोल तो जाइथिलु बाकी आपण दीटा जो ऑप्शन दोचन ना किछि मु पर्सनली कहउछि किछि पिला हाउछन जे हमर रीजन एई प्रॉब्लम सो करी के हम जीवानी भी
प्रॉब्लम ओनली इज कोविड जो थे तमे जीवानी बेली कहि परिबा एक्चुअली आ तुम माने के इंटरेस्टेड हो न आ मु देखुछि कि 15 नु 16 एठी क्लास अटेंड करछो ऑनलाइन कले आसिले 8 जण आछो मोर से कहया कथा कि अन्य मैंने आसबनी कहीं जदि यहाँ कोरोना फोरोना सिचुएशन न था तुम मूल क्लास आस ना कि तुम अटेंडेंस काउंट होता एमती जदि कर मोर किसी कहर ना एबे सिचुएशन मु तुमको स्ट्रिक्टली कहर ना मु तुमको स्ट्रिक्टली कहबी तुम पुणी कह मिछरे कह मोर यहाँ रोग है से रोग है सार आमको बाध्य कर कहते मु बाध्य करूना कि करी भी ना कि मु कहीदे जब तुम परीक्षा दे सार तापर देयर इज ए प्रॉब्लम जदि तुम लॉकडाउन होइतो इट्स ओके तुम घरे रुह हम ऑनलाइन क्लास करिया जदि लॉकडाउन है नथिबो मे बी यू हैव टू कम काहे कि ना some odd response is showing in our department. Only environmental science students are not coming. आउ समस्त फुल फ्लेज क्लास चलछि सो मु मोर कर्तव्य हला तुमको इन्फॉर्म करिया कि एंडिया सिस्टम गोटे चली छे मु एया कहूछि जे पिला माने इंटरेस्टेड नांती बहुत कम प्रॉब्लम अछि मानकर आउ किछ कहि भी पाउनी व्हाट इज द प्रॉब्लम तो क्वेश्चन आसेनी मु कहिनी क्वेश्चन आसिले देयर इज ए प्रॉब्लम कि मु कोन कहिबी मु एटलीस्ट कहबी नै गोटे पिला को एमती हेगला कि तार देह खराब अछि क्या कुटे कोरोना हेइथिला बा एबे कोरोना हेइछि बा श्रेयसी कथा कहि हेइथाना बट दैट इज ए लॉन्ग गैप मोर तो ऑलरेडी निजे ही मु कोरोना पेशेंट थिले
सर मु संबित सर को सहित कथा हेतिली से कहले तमे काई ऑफलाइन क्लासेस आसुचो एबे केते दिन ऑनलाइन क्लासेस कंटिन्यू करो
ऑनलाइन क्लासेस न हेले कोनटा कंटिन्यू करिवो संबित सर तो जानि ना सब कथा भी से तो ऑफिस असिस्टेंट इज ए क्लर्क सेटा जानन से ऑफलाइन क्लासेस निजे हमर हेड ऑफ द डिपार्टमेंट कोर्स कोऑर्डिनेटर जे डॉक्टर चिन्मय प्रधान सर बॉटनी रो क्लास निजे नउचंदी एवरी डे आउट ऑफ हिज आवर्स बट इफ यू पीपल आर नॉट कमिंग देन मु खार क्लास नेबी मु खुंटर क्लास नेबी की नहला नै मोर कुछ प्रॉब्लम नै आई डोंट हैव एनी
नहीं सर सर कहथिले कि सेमति किछि को स्टूडेंट ऊपर फोर्स नाही कि तमे आसिया पई फोर्स एमति फोर्स करूनु हमें आउ जदि तमे आसी पारुचो आसो नहले ऑनलाइन क्लासेस कंटिन्यू करो
ऑनलाइन क्लासेस न हेले केन कंटिन्यू करिवो श्रेया मु पचारुछि गोटे क्वेश्चन पचारुछि जदि ऑनलाइन क्लास हबन से 6 7 जन 8 जन जे भी आछन ताकर ऑफलाइन ने हमें पढेबो ताल कोन करिवो यू मिस द क्लासेस ना नै
यस सर
माने तमे गोटे कथा जानिबा दरकार कि तुमे तो टोटल क्लास आसिनो श्रेया से दास तुम तो जानि न भी माने व्हाट इज द यूनिवर्सिटी सिस्टम ऑफ एजुकेशन यू डिडंट नो ओनली ऑनलाइन क्लासेस करछो अन्य माने समस्त हेले आछन किछ किछटा क्लास गोटे दीटा पांचटा जा गेला आछन तो जानि भी पालन सेमिस्टरटा केमि सरला सेकंड सेमिस्टर भी सेम सर जीवो तो यू विल रिपीट आफ्टर सम टाइम मु काहे की कहूछ छाड़ जा करछो करो मोर किछ कहबार नै किंतु मने रखिथा ample of evidence आ ample of problem तमे accumulate करो दरकार पड़ले मु मागिले रिटर्न देई परथो नाइ सर हमर या प्रॉब्लम अछि तमे आसुन किछि नाइ मोर किछि नाइ मु आई विल एक्सेप्ट एवरी प्लीज और एवरीथिंग मु एक्सेप्ट करबी आ सेइडाई फॉरवर्ड करबी नाइ आज्ञा तार सेया प्रॉब्लम से आसुन तार या प्रॉब्लम से आसुन सेत पई हमर 10 15 जन आसुन हमें करूनो ऑफलाइन माने फिजिकल मोड रे ऑनलाइन ही करू हला मते बंचेया पई कि हेले तो मते इडा लिखि दबो दरकार पड़ले मु जदि मागी मते लिखि दबो काहे कि आसुन हो मो सेति कहर अछि तुम लिखि दउ न मते हेइतिला बेली करूना मोर किछ कहर नै तुम लिखियो फादर काउंटर साइन कर दो मोर रख दे सेडा पेपर प्रोसेस कर दे भाई क्या समस्त पर असुविधा अछि सर से माने आसी परिबेनी तो सेत हमरो हबनी माने फिजिकल मोड क्लास तो बुझी परनो मते कॉम्प्लेक्सिटीज फेस करिया पडुची से माने कोन लिखि कि देले नोटिस रे लिखि कि देले गवर्नमेंट कोन लिखि कि देछि तुमने ट्विटर हैंडल देखुचो यदि ट्विटर हैंडल देखुचो ठीक हायर एजुकेशन ट्विटर हैंडल देखिलो 16 अगस्त रु फिजिकल मोड क्लासरूम ऑन बेली ते ट्विटर हैंडल देखुनो मिनिस्टर को ट्विटर देखिलो हायर एजुकेशन मिनिस्टर अरुण सांगर से माने लिखि कि दउचने माने बुझो गवर्नमेंट हमको ऑर्डर करছে एटा आ हमर एटी एआई छै कि ब्लेंडेड मोड रे हबो क्लास माने 3-4टा पिला को हमर कोरोना अछि एबे ही तो हमें सेति पई कि गोटे ऑनलाइन क्लास भी रखिबु दी चारटा ऑनलाइन क्लास हो दी चारटा ऑफलाइन क्लास हो से दी चार जन को पाई कथा बुझुचो ना बुझुनो मु जानि मन मोर प्रॉब्लम तुम बुझी पारनो सेटा गोटे ऑफिशियली गोटे कॉन्फ्लिक्ट सिचुएशन हे जाउछ हौ देखो तुम मन तो आसुनो सेत पे मते एठी कहिया पड़ला हौ देखो तुम जा करछो करो मोर किछ कहया नै बट एटा चली जीवो नो प्रॉब्लम मो ऑनलाइन क्लासेस आउ कर दबा माने सेकंड सेमेस्टर गोटे दीटा क्लास कर दे के ब्रेक कर दो सेमेस्टर ब्रेक तुम फर्स्ट सेमेस्टर परीक्षा दियो किंतु आफ्टर एग्जामिनेशन यू विल थिंक कि तुम लिखिक दब कि आमको समस्त ऑनलाइन करार अच्छे आम समस्त या देह खराब अच्छे बा जो मानकर अच्छी से लिखिक दे दब बस अकॉर्डिंगली विल प्रोसेस है डोंट वरी see you in the next class no problem that's all for today